What exactly lies at the edge of the observable universe? Well, this has remained a mystery for centuries, fueling curiosity and speculation among scientists and enthusiasts alike. However, the James Webb Space Telescope holds the key to unveiling this cosmic mystery with its powerful lenses peering deeper into space. It has recently made a groundbreaking announcement of what lies at the edge of the observable universe. When we talk about the edge of the universe, it's essential to understand the concept of the observable universe. The observable universe includes everything that we can see, measure, and study from Earth or our space-based telescopes and exploratory probes. At the present time, it consists of stars, galaxies, and other celestial objects that are within our observational reach. So, what's the difference between the universe with a capital U and the observable universe? In simple terms, the observable universe is just a small fraction of the entire universe that we can study and comprehend. While the complete size and shape of the entire universe are unknown, there is an estimated diameter of the observable universe, which is around 93 billion light-years. Now, a light-year is a unit of distance that light travels in 1 year, which is about 5.88 trillion miles or 9.46 trillion kilometers. So, the diameter of the observable universe, 93 billion light-years, is an unimaginably vast expanse, spanning approximately 5,468 billion trillion miles or 878.4040. Expanding at an increasingly faster pace driven by enigmatic forces like dark energy. As the universe expanded, particles of matter started clustering together due to the force of gravity, forming or inspiring structures such as stars, galaxies, and eventually even planets like our beloved Earth. Over countless years, these cosmic structures grew larger and more intricate, leading to the extraordinary diversity of objects and phenomena that we observe throughout the universe today. Despite the vastness of the universe, it is predominantly empty. To put it in perspective, if we scale down our entire solar system to the size of a quarter, the nearest star would still be the distance of 2 soccer fields away. And this is just within our Milky Way galaxy, which is one among billions in the observable universe. You may wonder, why can't we see the entire universe? There are 2 factors that explain this. The first reason is that light takes time to travel through space. When we look at distant objects in the universe, we're actually observing them as they were in the past. The farther away an object is, the longer its light has taken to reach us. So, by observing distant galaxies, we're essentially peering back in time, unraveling the history of our cosmos. The second reason is the universe's expansion. Imagine dots on the surface of an inflating balloon. As the balloon expands, the dots move away from each other. The same principle applies to the universe, where galaxies are drifting apart as space itself stretches. This expansion causes the light from distant objects to become stretched, shifting towards longer wavelengths, which we perceive as redshift. Eventually, some objects will move beyond our observational reach as they recede beyond a certain distance. Considering these factors, it's not surprising that we haven't seen the entire universe yet. Now, the concept of the edge of the universe is a mind-boggling topic that has fascinated scientists, philosophers, and thinkers for ages. We have all sorts of theories about what lies beyond, but the truth remains elusive. However, there are 3 theories that stand out. The first theory is that the universe goes on forever, with no end in sight. This theory is based on the cosmological principle, which states that the universe is isotropic, meaning that it looks roughly the same in every direction. If this principle holds true, it implies that the universe stretches on endlessly without a boundary. The second theory suggests that the universe is finite, but it doesn't have a clear edge either. This means it's similar to a giant ball, and if you keep going in any direction, you'll eventually loop back to where you started. The third theory is the multiverse theory, which suggests that our universe is just one of many. Imagine a bunch of parallel universes, each with its own set of rules and properties. These universes could be completely separate from each other or somehow connected. So, we've talked about concepts surrounding the edge of the universe by looking at diverse theories. Now, let's turn our attention to a remarkable tool that holds the potential to shed light on these mysteries, the James Webb Space Telescope, JWST. This incredible telescope allows us to look far back in time and discover unexpected objects from the early days of the cosmos. The JWST, with its advanced capabilities, has enabled astronomers to peer back into the early days of the universe. And guess what? They've stumbled upon something unexpected. In a recent study published in the journal Nature, the JWST discovered 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang. Researchers were only expecting to find small, newly formed galaxies, but the JWST caught them by surprise. These galaxies are way larger than anyone ever imagined, challenging what we thought we knew about the early cosmos. But that's not all. Scientists also found something mind-boggling. These galaxies are as mature as our 13-billion-year-old Milky Way galaxy. The mass of stars within each of these objects totals several billion times larger than that of our Sun. According to the research, one of them in particular might be as much as 100 billion times our Sun's mass. For comparison, the Milky Way contains a mass of stars equivalent to roughly 60 billion suns. You see, this telescope has a special power. It can see things that are invisible to our eyes. By using infrared light, it picks up the faint glow from old stars and galaxies that have been around for ages. This means the JWST can literally take us back in time, providing a glimpse of what the universe looked like around 13.5 billion years ago. Now, here's where it gets really interesting. The universe is estimated to be around 13.7 billion years old. So, this discovery has turned things upside down. It's like rewriting the history books. These gigantic galaxies, nicknamed universe breakers, have scientists scratching their heads. They defy 99% of the models we had for early galaxies. We used to think galaxies started as small clouds of stars and dust, gradually growing over time. Well, these universe breakers proved us wrong. When the Webb data and high-resolution photos from the telescope became available in July 2022, researchers were blown away. They were taken aback when they saw these galaxies as significant points of light, doubting their own interpretation of the data. The sudden appearance of these colossal objects, almost as if they wanted to be found, surprised everyone. By using spectroscopic techniques to analyze light across different wavelengths, scientists can uncover valuable information about these galaxies, such as their composition, size, and distance from Earth. What's fascinating is that this groundbreaking discovery wasn't even on the top of the list of things scientists hoped to find with the James Webb Telescope. It exceeded all expectations and unfolded much quicker than anticipated. There's even a possibility that some of the objects found using Webb data may be something entirely different. While most are likely galaxies, there's a chance that a few could be hidden supermassive black holes. Meanwhile, using the powerful James Webb Space Telescope, JWST, an international team of astronomers also made an incredible discovery. They found the oldest and farthest galaxies ever confirmed. These galaxies take us back to a time when the universe was just a fraction of its current age, fewer than 400 million years after the Big Bang. The light from these galaxies reached us more than 13.4 billion years ago, as detected by the telescope. Similar to the early observations made by the Hubble Space Telescope, the initial images captured by the JWST revealed numerous potential galaxies. Now, through meticulous spectroscopic observations, astronomers have confirmed 4 of these objects, allowing them not only to study the physical properties of the galaxies but also to accurately determine their distances. To determine a galaxy's distance, astronomers calculate its redshift. You may be wondering, what is redshift? Well, it turns out that as the universe expands, objects appear to move away from us, causing their light to stretch and shift toward longer, redder wavelengths, a phenomenon known as the Doppler effect. While redshift estimates can be derived from photos taken through various filters, spectroscopy is the preferred method for obtaining precise measurements, as it breaks down the object's light into its constituent wavelengths. The new discoveries focus on galaxies with redshifts greater than 10. This means they are super far away. The Hubble Space Telescope previously spotted 2 of these galaxies, and their redshifts were confirmed to be 10.38 and 11.58. But the JWST images revealed 2 even more distant galaxies with redshifts of 13.20 and 12.63. Redshift 13.22 indicates a time period roughly 13.5 billion years ago, revealing ancient cosmic history. Moreover, the JWST's Advanced Deep Extragalactic Survey, JADES, is an ambitious program that has been allocated over a month of the telescope's time. Its objective is to provide an unprecedented in-depth glimpse into the early cosmos. In 2015, a consortium of instrument teams proposed this project, forming an international partnership known as JADES, comprising more than 80 astronomers and scientists from 10 different nations. Beginning with NIRCam, the JADES program dedicated over 10 days of mission time to observing a small region of the sky, including the Hubble Ultra Deep Field. For over 2 decades, astronomers have been exploring this region using various large telescopes. By studying the field in 9 different infrared wavelength bands, the JADES team made a remarkable discovery: nearly 100,000 distant galaxies, each billions of light-years away. Next, using the NIRSpec spectrograph, the scientists collected light from 250 faint galaxies during a 3-day observing period. This enabled them to reveal the characteristics of the gas and stars within these galaxies and obtain precise redshift values. With these measurements, astronomers can determine the intrinsic brightness of the galaxies and estimate the number of stars they contain. This allows for a comprehensive examination of galaxy formation over time. Even without direct knowledge of their early growth stages, studying galaxies can be as challenging as understanding human beings. The early generations of stars have a profound impact on the future of galaxies, much like how our early experiences shape our lives. This is an extraordinary time in history when the transformative capabilities of the Webb telescope are answering numerous questions about galaxies. NASA's Deep Space Observatory Telescope is revolutionizing our understanding of the cosmos and unveiling a treasure trove of new discoveries. The James Webb Space Telescope, Webb, a pioneer in scientific research, is providing us with astonishing insights into galaxies, planets, stars, and other captivating cosmic phenomena. Launched in December 2021 and expected to operate for 2 decades, Webb is just embarking on its cosmic adventure, surpassing the standard set by its predecessor, the Hubble Space Telescope. Webb has captured the imagination of scientists and the public alike, inspiring a wave of scientific enthusiasm. People worldwide are eagerly modifying the telescope's raw data, sharing its breathtaking photos, and gaining fresh perspectives. Following a flawless deployment process, Webb astonished us with its initial photographs in mid-July, granting us an unprecedented view of our universe's myriad aspects. With the help of its advanced infrared telescope, we can explore the farthest galaxies in remarkable detail and peer into the depths of the past. Within days of going online in late June 2022, Webb's powerful instrument started revealing thousands of previously unknown galaxies, older and more distant than ever imagined. Moreover, the telescope's capabilities enable scientists to gather abundant light from celestial objects such as exoplanets and newborn stars, unveiling their compositions and tracing their trajectories through space. This wealth of data is already unveiling intricate details about the atmospheric compositions of planets located hundreds of light-years away from Earth, hinting at their potential habitability. But not just that, by analyzing faint traces of light from the universe's infancy, the James Webb Space Telescope has potentially identified the oldest black hole ever observed. This supermassive black hole, with a mass 9 million times that of the Sun, resides at the core of a young galaxy that formed 570 million years after the birth of the universe. Thanks to Webb's powerful cameras, capable of peering back in time to the cosmos' earliest moments, this monumental discovery offers insights into the cosmic dawn when numerous black holes grew in size over the course of 1 billion years following the Big Bang. The origins and proliferation of these enigmatic cosmic entities remain mysteries that puzzle astronomers. Some of these massive cosmic disruptions emit light observable by telescopes, created by the friction of material spiraling into their gravitational abyss. These objects, known as active galactic nuclei, AGNs, supermassive black holes, or quasars, are billions of times more massive than the Sun, radiating intense bursts of light trillions of times brighter than the brightest stars. They represent the most extreme form of AGN. As scientists venture deeper into the cosmos, they can capture light from more distant sources, providing glimpses into earlier stages of the universe. The James Webb Space Telescope, JWST, employs its mid-infrared instrument and near-infrared camera to scan the sky, searching for black holes. Its built-in spectrographs then separate the light spectrum into different frequencies, allowing scientists to analyze the data. During their investigations, scientists made a crucial discovery: the heated material surrounding a black hole emitted faint traces of radiation across the universe. By scrutinizing these delicate glimmers from the universe's infancy, they detected an unexpected surge among the frequencies embedded within the light, providing valuable insights into the cosmic processes at play. The rapid appearance of black holes in our young cosmos remains a mystery. Scientists continue their search for much younger primordial black holes, which are believed to have formed right after the Big Bang or possibly even earlier. However, these elusive objects have yet to be discovered. Meanwhile, two main explanations exist for the abundance of black holes in the present universe. One possibility is that they are remnants of massive stars that formed much more rapidly than the stars we observe today. Alternatively, it's proposed that dense clouds of gas suddenly collapsed to form these enigmatic singularities in space-time. A more probable scenario involves a population 3 star, a hypothetical class of stars that emerged about 200 million years after the Big Bang. Primarily composed of hydrogen and helium, such a star would have exploded, leaving behind a black hole. Subsequently, the black hole would have grown in size by rapidly accumulating matter at a rate exceeding stability. Scientists are collaborating with the team behind the development of MIRI to study the far-off galaxy S-light and seek additional clues about the formation of the enigmatic black hole at its center. Scientists have also examined the early stages of the universe and observed the formation of a protocluster comprising 7 interacting galaxies. This cluster, discovered by the Hubble Space Telescope, is the most distant galaxy cluster identified by researchers. Simulations suggest it will eventually become one of the oldest and largest known galaxy clusters in the universe, with a mass nearly 100 times greater than that of our Milky Way galaxy. While the initial discovery of these galaxies was made by the Hubble Space Telescope, it lacked the sensitivity to precisely measure the distances between them. Despite their alignment along the same line of sight, imagine being high above Los Angeles and peering through a telescope. You might see Phoenix, Dallas, and Atlanta, but you wouldn't know the precise distances separating them, right? But thanks to the James Webb Telescope, we got to see a much clearer picture. These kinds of clusters, according to scientists, are extremely unusual and difficult to locate. Although it's unlikely that the JWST will discover another unique system like this, the future Nancy Grace Roman Space Telescope, set to launch in early 2027, will enhance our ability to identify galaxy clusters in the early universe. Its wide area survey capabilities will surpass the JWST by over 100 times. Back to the discoveries made by the JWST, in the 1990s, astronomers made groundbreaking exoplanet discoveries thanks to this revolutionary telescope. We now know of over 3,000 extrasolar planets, although only a dozen have been directly photographed. Most exoplanets are so distant that we can only observe them when they transit in front of their host stars, causing a slight dimming of light. However, the JWST has changed the game. Using the telescope's coronagraphs combined with its cameras, filters, and other equipment, scientists can directly observe exoplanets. In 2017, the Sphere Consortium made a significant discovery by identifying a planet called HIP 6542-6b using the Spectropolarimetric High-Contrast Exoplanet Research (SPHERE) instrument. HIP 6542-6b is an exoplanet that orbits its host star, HIP 6542-6. In September 2022, it gained further attention as the first exoplanet to be directly observed by the James Webb Space Telescope. What makes this planet particularly intriguing is its unique characteristics. Combined with the remarkable sensitivity of the James Webb Telescope, which allows for easier observation, unlike any other planet in our solar system, HIP 6542-6b is situated at a distance from its host star that is 100 times greater than the distance between our Sun and Earth. To give you some perspective, Pluto is just 40 times farther from the Sun than Earth. Now imagine an exoplanet that's a colossal gas giant about 12 times the size of Jupiter, even though the phantom galaxy is elusive in the night sky. Its brilliance is still visible, especially when captured by Webb's infrared camera. When we look at the galaxy known as M74, we are treated to a stunning view of its beautiful spiral shape and the dispersion of stars. The galaxy's radiant center gives birth to arms that stretch outwards. Hubble's optical view of this object showcases its splendor, also revealing structures resembling heat-emitting dust and gas fibers that emanate from a bright center, all depicted in a striking electric blue. While in the image captured by Webb, we witness the illumination of star-forming areas scattered throughout the spiral arms. Thanks to its infrared capabilities, combining photos from the Hubble Space Telescope and Webb, researchers have created a breathtaking composite image. This composite highlights both the optical and infrared views of the galaxy, providing a more comprehensive understanding. As part of an international project, these 3 photographs were featured in a film, allowing astronomers to compare them side by side. Through this process, they were able to identify regions where stars are currently forming and gain precise calculations of star cluster masses and ages. Additionally, Webb studies have provided valuable insights into the characteristics of tiny dust particles moving through the vast expanse of interstellar space. Webb also captured an image of a far-off Wolf-Rayet star, which displayed a unique diffraction pattern. The star, known as WR140, is surrounded by a ripple-like arrangement of concentric rings, giving it an oddly boxy shape. Surprisingly, these distinct ring formations are not imaging artifacts, but actual characteristics of the star. These massive stars are reaching the end of their lifespan and have already released a significant amount of hydrogen into space. The interaction between WR140 and its small companion star molds a cloud of dust into the shape of their neighboring star, resulting in the peculiar shapes of the rings. In the constellation Virgo, the most extensively studied exoplanet outside our solar system orbits a star. This planet, named WSP-39b, resides a staggering 700 light-years away from Earth. It's a scorching gas giant, comparable in size to Saturn, orbiting its host star at an astonishingly close distance, roughly 8 times nearer than Mercury is to the Sun. Ultimately, Webb was designed to venture to the farthest reaches of the universe, and researchers have confirmed its success in doing so.